Assalamu alaikum. I am Sabrina Tasneem. My matric number is G2515946. First year student, PhD, KICT IIM. So now I'm starting my slideshow here. Just a minute. So today I'm presenting my individual assignment titled Comparative Methodological Analysis CNN versus Transformer Model for detecting early stage pneumonia using chest X-ray. I think this should be bottom. Okay. So this study focuses on a structural methodological comparison between two major deep learning architecture. One is convolutional neural networks and vision transformers. Rather than conducting new experiment, basically this research critically analyzes the architectural principles, data consideration, evaluation strategy, and practical feasibility in medical imaging. Moving to the next slide. Okay. So the research the research aim and questions. The primary aim of this study is to conduct a methodological comparison between CNN and transformer architecture for pneumonia detection using chest X-ray images. The key research question can be they are firstly, what are the architectural differences between CNN and transformer models? Then the second one is what are the strength and limitation of each approach in medical image classification? And the last and third one is what research gaps still remain unresolved in current deep learning based pneumonia detection study. So this question guide the analytical structure of this research. Scope and methodology. So this research adopts a conceptual and analytical approach rather than performing new experiment actually. The study follow four phases. We can say data understanding, model analysis, evaluation strategy, and comparative interpretation. If we focus on data understanding, that means examining the dataset characteristics. Then in model analysis, we can say reviewing the CNN and transformer mechanisms. And the third one is evaluation strategy, that means analyzing the performance metrics. And last one is comparative interpretation, means synthesizing strength, limitation, and feasibility. Okay, so the focus is strictly on image classification using chest X-ray. It doesn't include segmentation tasks or CT scan analysis. The goal is to evaluate methodological soundness and practical applicability. Okay, so the in slide 4, we are seeing that convolutional neural network. What is this actually? So it is shortly say CNN, operate using convolutional and pooling layers to extract hierarchical spatial features. In pneumonia detection, early layer capture edges and textures, deeper layer learn more complex pathological pattern. CNN have a strong inductive bias towards spatial locality, meaning they are naturally suited for structured image data like X-ray. Also, their strengths include efficient training, stable optimization, good performance even with limited dataset, and easier deployment in low resource environment. However, CNN also struggle or may struggle to capture global contextual relationship across distant region of the image. That can be problematic when disease patterns are diffuse. So this is CNN. Next models we are using here is transformer based model. Vision transformer process image differently than CNN actually. So instead of convolution, they divide the image into fixed size patches. So each passage is converted into a token, embedding and processed using a self-attention mechanism. Uh, Self-attention allow the model to examine the relationship between all image regions simultaneously. So this gives transformer a global receptive field. So their strength can be, we can say, excellent model of long range dependency and a better capture of global anatomical pattern. And there are some also limitation. It can be high computational requirement because transformer needs very high computational requirements. Large data dependency, it works on large data set. Risks of overfitting in small medical data sets and interpretability challenges. So while powerful, transformer may not always be practical in healthcare setting. In slide 6, we see the comparative insights. When comparing CNNs and transformers methodologically, several insights can be emerged. CNN often outperform transformers when datasets are very small because their inductive bias help them generalize better way. But transformer trains to perform better on very large dataset. Whenever we have large dataset, we can go for the transformer, where global context modeling become advantageous. And in hybrid CNN transformer architecture attempt to combine local feature extraction from CNNs and global attention modeling from transformer. However, this hybrid model increase the complexity, deployment trade-off must consider computational cost, training stability, reproducibility, and infrastructure availability. Therefore, model superiority depends on context, not architecture alone. Move to the slide 7. Next slide, actually. Um, common commonly used dataset are like NIH checks X-ray 14, Carmeny pediatric pneumonia dataset. Medical datasets often suffer from like class imbalance, image variability, different preprocessing methods. So in evaluation, accuracy alone is insufficient. Clinically important metrics include like sensitivity, because missing pneumonia case is very dangerous. Specificity. A major methodological issue is the lack of a standardized evaluation protocol and making fair comparison that can be difficult. Moving to the next slide. What are the research gaps, ethics, and future direction? This study basically identifies several gaps. If we go one by one. So first, there are limited direct methodological comparison between CNN and transformer architecture in medical imaging. And next, we can go to the second by few study analyze how dataset size affect architecture performance. And third, reproducibility remains a challenge. From an ethical perspective, we can say patient privacy, dataset bias, fairness across demographics. These are the ethical perspectives. And future direction in this sector, I can say hybrid architectures, external validation on diverse dataset, explainable AI integration for clinical trust. So now we are at the last conclusion. In conclusion, there is no universe winner between CNN and transformer model. CNN are efficient, stable, suitable for limited data and low resource settings. Wherever transformers are powerful for global context modeling, better suited for large scale data set, and computationally very expensive. Model selection should depend on dataset size, clinical requirements, available computational resource. For practical healthcare deployment, methodological transparency, under standardized evaluation, and ethical safeguard must be prioritized. So this is all about my task. Thank you so much for all. We have learned great things and very effective points in this course that will be a life learning situation actually. Just a minute. Let me. Okay, so thank you so much. We have learned a lot in this course. Thank you, and please keep us in your prayers, ma'am. Thank you so much.